description of the basic elements of the circuit or the network. Now in this video we are going to discuss about some more details about these basic elements. Along with that, some of the laws like Kirchhoff's voltage law, Kirchhoff's current law, and some of the theorems. One of the theorems, superposition theorem. Now coming to our segregation of the elements in any circuit or the network. So here the circuit is nothing but interconnection of the elements which have at least one closed path. Which have the interconnection of the elements which have at least one closed path is the circuit. So the elements that we have already discussed is the previous elements that we have already basic elements discussed is resistor, inductor, capacitor, and along with that some of the sources. Now in this video we will go through what is the nature and how they are able to discriminate from one another. We will see now. Coming to the elements, type of elements can be either linear elements or non-linear elements. In case of linear elements, here the voltage and current relationship, here you can observe here, this is the voltage and current. The voltage versus current relationship must be either it can be in a linear form or it can be a non-linear form. So if the applied voltage, if it changes linearly with the applied voltage, then that type of element can be called as linear. So example for that is a resistor, inductor, and capacitor. So generally the linear elements obey is Ohm's law. Coming to the non-linear elements, so these do not change linearly with the applied voltage. Whatever the element that you are considering, if it does not change linearly with the applied voltage, that is known as the non-linear element. The example for that is diode, voltage dependent resistor, voltage dependent capacitor varactor, and temperature resistor, temperature dependent resistor thermistor, and then light dependent resistor LDR. All these are comes under the non-linear elements which do not follow voltage and current relationship in a linear form. So, and one more thing is non-linear elements do not obey Ohm's law. Now coming to the next type of elements can be possible to occur in your circuit is either the active elements or the passive elements. So what is active element here is if the element is capable of giving the signal energy, providing the signal energy, or it increases the signal energy is nothing but the active element. So the example for the active elements is voltage source, current source, batteries, BJTs, FETs. All these are comes under the case of active elements. Now coming to the passive elements, these cannot provide the signal energy and it cannot increase the level of signal energy also. So those passive elements can be, these passive elements always take the energy from the sources or the active elements. So passive elements example is resistor, inductor, capacitor, VDR, LDR, and thermistors. Now coming to the one more type of elements is either unilateral and bilateral elements and lumped and distributed elements. Now come to the case of unilateral. So if the magnitude of the current changes when the polarity of the applied voltage changes, then that type of element can be unilateral. The example for this is diode. Now coming to the bilateral, the magnitude of the current does not change when the polarities of the applied voltage changes. Polarities of the applied voltage changes. That the example is resistor, which is the bilateral element. Now coming to the lumped and distributed elements, lumped means if the elements are able to separate it physically for any analysis, those type of elements are lumped elements. And the example for that is resistor, inductor, and capacitor and all. Now coming to the next one is distributed. So element cannot be separated physically, cannot be separated physically for any analysis. That type of elements are known as distributed elements, and the example is transmission lines. Along with these cases, we also have one more, that is time invariant and time variant networks. So time invariant means if the input-output relationship, if it does not change with the time period, that type of elements is time invariant and the circuit is time invariant circuit. Now coming to the time variant, if the input-output relationships are change with time, then that is known as time variant. Now coming to, so when you have different types of elements like whatever that we have discussed till now, either passive elements or active elements, and combination of active and passive elements in a particular circuit, and there is a possibility of different types of connections. Now this is one type of series connection, another one is parallel connection. Now coming to the series connection, one terminal of the element will be connected to other terminal of the element. And one more thing is, if you observe the current pass through these R1, R2, R3, these are the three resistors which are interconnected to one another in this circuit, and voltage source is the energy that is supplied. V is the voltage source or the active element, R1, R2, R3 are the passive elements. Those are connected by forming a closed path. Here, because of this closed path, there is a current that is flowing through the circuit, that is I. And here this I is throughout all the resistors is same. The current through all the resistors is same. So now look at here, because according to the Ohm's law, we know that V equal to IR. So here, if I consider the voltage across this closed path, V equal to V1 plus V2 plus V3. So the total current that is flowing through, or the voltage applied across the source is the total current into total resistance into I that is flowing through the circuit. So individually, if I write the Ohm's law and if I write down, the total equivalent resistance will be R1 plus R2 plus R3, because all these are connected in series. And then the total current I equal to V by R1 plus R2 plus R3. Coming to the parallel connection, so coming to in case of the series connection, the current through all the elements will be same. But in case of the parallel connection, voltage across the resistors or voltage across all the elements will be same. Voltage across all elements will be same, and here the current that is entering at this node divides between each and every branch. The current divides between each and every branch. In the case of series connection, the voltage will divide across each and every element. Across each and every element, the voltage will not same, but current is same. In the case of parallel connection, current is different or changes, voltage will be same. So according to that, if I write I equal to, here I is entering at this node and the leaving currents are I1, I2, I3. So entering current must be leaving current. From that, if I apply Ohm's law and find out the equivalent resistance, 1 by RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance of the parallel connection of the resistors. Now coming to the voltage across that particular each and every element, or the total resistance and the voltage, the current multiplied together, will get either R1 I1 or I2 R2 or I3 R3. Both three of them are equal. This is about the parallel connection. Now coming to other laws that are very important in this basic